Hello, welcome to Astronautics for Exploit. I am Dr. Anyashola Ogundele, and I will be presenting InOrbit LEO economic companies. The overview of my presentation is as follows. InOrbit LEO economic companies. For several decades, human imaginations about space have prompted and spurred various research, innovations, and venturing into space. The potentiality of being able to manufacture in space is a booster for successful and continuous space exploration, space tourism, and creation of a robust low Earth orbit economy, which will make space more accessible. This will lead to the increase in deep space exploration efforts and helps to solve many problems facing the Earth. In LEO, some of the various activities that have the potential of increasing LEO economy and InOrbit LEO space transportation, InOrbit LEO space manufacturing, InOrbit LEO space gas station and refueling, and InOrbit LEO space station. Several companies such as Asian Space, SpaceX, NanoRacks, Blue Origin, and Think Orbiter, and Leap Biosystems are making efforts to make a significant difference and enormous contributions to the LEO economy by engaging in InOrbit LEO economic activities. Asian Space is presently investing in the design of building the world's first commercial space station, which will serve as a home to human-tended microgravity research, testing of critical space environment materials, product development, and in-space manufacturing. ASEAN's main goal is to make the microgravity environment more accessible and cost-efficient to unlock the potential it holds for innovation and discovery, which could not possibly be done on the Earth. Spaceflight is revolutionizing the business of in-space transportation through its comprehensive suite of launch services and sharper orbital transfer vehicles. Think Orbiter is designing and manufacturing high-volume, cost-efficient habitable space structures for low Earth orbit and beyond. Leap Biosystems is combining clinical medicine with innovation and disruptive technologies for human space exploration. Orbit Fab is working to create all the necessary technology for orbital refueling services for satellites. Blue Origin is working to develop Orbital Reef, a commercially owned and operated space station to be built in low Earth orbit. All the InOrbit LEO economic companies are aiding evolution of the LEO economy, which is based on the production, distribution, and trade of goods and services within low Earth orbit. InOrbit. An orbit is a regular repeating path that one object in space takes around another one. An object in an orbit is called a satellite. A satellite can be natural, like the moon, the Earth's moon. Many planets have moons that orbit them. A satellite can also be man-made, like the International Space Station. This picture shows the Jeff Bezos Blue Origin and Shira Space private space station for new business park in space that is being proposed. Objects orbiting the Sun. Planets, comets, asteroids, and other objects in the solar system orbit the Sun. Most of the objects orbiting the Sun move along or close to an imaginary flat surface. This imaginary surface is called the ecliptic plane. This picture shows NanoRacks Starlab commercial space station to be stationed at low Earth orbit. LEO's proximity to Earth. Time to circle the Earth. Satellites in low Earth orbit travel at a speed of around 7.8 kilometers per second. At this speed, a satellite takes approximately 90 minutes to circle Earth, meaning the International Space Station travels around Earth about 16 times a day. This picture shows view of Earth from the cupola during Expedition 43. In-orbit LEO economic companies. Some of the in-orbit LEO economic companies are and operations that they involve in are InOrbit LEO Space Transportation, InOrbit LEO Space Manufacturing, InOrbit LEO Space Gas Station and Refueling, and InOrbit LEO Space Station. InOrbit LEO Space Transportation. Space transportation is the transportation by means of vehicles designed to operate in free space outside the Earth's atmosphere. Space transportation systems are the systems and architectures that deliver payloads and humans to outer space. This picture shows taking off of the SpaceX Falcon 9 rocket to low Earth orbit for the first time since the conclusion of the Space Shuttle program in 2011. Spaceflight Inc. In space transportation. Spaceflight is revolutionizing the business of in-space transportation through its comprehensive suite of launch services and sharper orbital transfer vehicles. This picture shows an artist's concept of spaceflight sharper torque, which is planned to be launched on SpaceX Falcon 9. Spaceflight Inc., the global and premier launch services provider, is actively planning several sharper orbital transfer vehicle missions to support in-space transportation efforts in low Earth orbit, geosynchronous equatorial orbit, and other cislunar destinations. This picture shows spaceflight's SSOA, dedicated ride-share mission with no large primary payload. In-space transportation is embarked upon by the Spaceflight Inc., and the reason being that to have a viable option to achieve orbital diversification, including flexible manifest changes, deployment of spacecraft into multiple altitudes and orbital planes, and rapid launch solutions. This picture shows artist illustration of spaceflight free flyers and payloads on the Falcon 9 rocket's second stage. In-orbit LEO space manufacturing. In-space manufacturing, which is also referred to as in-orbit manufacturing, involves a comprehensive set of processes aimed at the production of manufactured goods in the space environment. Currently, in-space manufacturing capabilities are limited to low Earth orbit. This picture shows demonstration of on-orbit satellite servicing, repairing, refurbishing, and refueling satellites. LEO in space manufacturing. The supporting points are as follows. The space environment, such as effects of microgravity and vacuum, enables the research of and production of goods that could otherwise not be manufactured on Earth to be possible in low Earth orbit. The extraction and processing of raw materials from other astronomical bodies referred to as in situ resource utilization could enable more sustainable space exploration missions at reduced cost compared to launching all required resources from Earth. This picture shows an artist's impression of an asteroid mining outpost. Another supporting point for LEO in-space manufacturing is that raw materials could be transported to low Earth orbit where they could be processed into goods that are shipped back to the Earth. By replacing terrestrial production on Earth, This will help in preserving the Earth. Raw materials of very high value, for example, gold, silver, or platinum, could also be transported to low Earth orbit for processing or transfer to Earth, which is thought to have the potential to become economically viable. This picture shows wake shield facility deployed by the Space Shuttle's robotic arm. Examples of LEO in-space manufacturing companies are Think Orbiter, which is designing and manufacturing high-volume, cost-efficient habitable space structures for low Earth orbit and beyond. Solar foods, that is food for Earth, food for space. Natural protein production anywhere by using air and electricity. This picture shows Asian Space proposed space station. Asian Space is making progress on its mission to provide access to in-space manufacturing. Another example of LEO in-space manufacturing companies is Orbital Assembly, known as Gateway Foundation, the first large-scale space construction company which is designed to build any structure in space quickly and with precision. Leap Biosystems is another in-space manufacturing company. Its mission is to combine clinical medicine with innovation and disruptive technologies for human space exploration, by translating this back to provide cutting-edge medical care here on Earth. This picture shows an artist's conception of a future satellite building scaffolding. Made in Space Inc. is another LEO in-space manufacturing company. Made in Space, whose primary mission is to enable humanity to become a multiplanetary species, specializes in the engineering and manufacturing of three-dimensional printers for use in microgravity. Made in Space 3D printer, 0G printer, was the first manufacturing device used in space. This picture shows illustration of onboard servicing, manufacturing, and assembly. InOrbit LEO gas stations and refueling. Gas stations in space. Orbit Fab is working to create all the necessary technology for orbital refueling services for satellites. Orbit Fab refueling service architecture consists of tankers in various orbits and shuttles that will deliver fuel from those tankers to clean spacecraft. Rapidly attachable fluid transfer interface, a fueling port that will allow for orbital refueling for satellites, is Orbit Fab first product. This picture shows Orbit Fab's refueling network concept. Orbit Fab's goal is to create a thriving in-space market for products and services that support both existing space businesses, communication and Earth observation, and new industries like space tourism, manufacturing, and mining. This picture shows the design concept of Orbit Fab's tanker mounted on a spaceflight shuttle in transit to geostationary orbit. InOrbit LEO Space Station. A space station is an artificial structure placed in orbit and having the pressurized enclosure, power, supplies, and environmental systems necessary to support human habitation for extended periods. This picture shows International Space Station. Space station as a base for various purposes. A space station can serve as a base for various purposes such as observations of the Sun and other astronomical objects, study of Earth's resources and environment, and investigations of the behavior of materials and biological systems, including human physiology and biochemistry, in a state of weightlessness or microgravity. This picture shows an astronaut performing spacewalk. Space stations can be categorized into two. We have small space stations, which are launched fully assembled, and larger space stations, which are sent up in modules and assembled in orbit. A space station is launched vacant, and its crew members and additional equipment follow in separate vehicles. A space station's operation requires a transportation system to vary, cruise and hardware, and to replenish the propellant, air, water, food, and such other items as are consumed during routine operations. This picture shows inside Orbital Reef Space Station. Space station can be classified into two: government space station and commercial space station. Government space station. International space station. All crewed space stations to date have been within low Earth orbit. International Space Station is a large spacecraft in orbit around Earth and serves as a home where crews of astronauts and cosmonauts live. Unique Science Laboratory. International Space Station, a unique science laboratory, is in a LEO about 400 kilometers, that is 250 miles, to 420 kilometers, that is 260 miles above Earth's surface, and needs reboosting a few times a year due to orbital decay. This picture shows International Space Station. Several nations work together to build and use International Space Station. The station is made of parts that were assembled in space by astronauts. International Space Station orbits Earth at an average altitude of approximately 250 miles and travels at 17,500 miles per hour. And this means that it orbits Earth every 90 minutes. The space station is being used to learn more about living and working in space. And this lesson will make it possible to send humans farther into space than ever before. This picture shows few of Earth taken during ISS Expedition 43. Commercial Space Station. Bigelow Commercial Space Station is a private orbital space station under conceptual development. On 8 April 2016, NASA launched a Bigelow inflatable module and attached it to space station, where it has been tested for over 4 years. This picture shows Bigelow Space Station concept. Axiom Commercial Space Station. The Axiom Station is a commercial laboratory and residential infrastructure in space that will serve as a home to microgravity experiments. The company is planning commercial missions in 2022 to the International Space Station and aims to own and operate the world's first commercial space station in 2024. This picture shows proposed Asian Commercial Space Station. Blue Origin Orbital Reef. Blue Origin Orbital Reef. To develop Orbital Reef, a commercially owned and operated space station will be built in low Earth orbit, and Blue Origin and Sirius Space partnered on this. It was proposed that Orbital Reef will start operating in the second half of this decade. This picture shows Blue Origin Orbital Reef private space station for building a business ecosystem in low Earth orbit. Orbital Reef partnership includes Boeing, Redwire Space, Genesis Engineering, and Arizona Space University. Orbital Reef, a human-centered space architecture, is designed to be a mixed-use space business park that provides essential infrastructure needed to support all types of human spaceflight activity in low Earth orbit and can be scaled to serve new markets. This picture shows inside of the Orbital Reef Space Station. NanoRacks Starlab. NanoRac's commercial low Earth orbit destination, in collaboration with Voyager Space and Lockheed Martin, is called Starlab. Starlab, which will be positioned at low Earth orbit, is targeted for launch in 2027 on a single flight as a continuously crewed commercial space station dedicated to conducting advanced research, fostering commercial industrial activity. This picture shows rendering of greenhouses operating inside a Starlab outpost. Starlab is designed for 4 astronauts and will have power, volume, and a payload capability equivalent to the International Space Station. Starlab will host the George Washington Carver Science Park, featuring 4 main operational departments: a biology lab, plant habitation lab, physical science and materials research lab, and an open workbench area, so as to meet the needs of researchers and commercial customers for commercial space activities. This picture shows design concept of NanoRac's Starlab. Northrop Grumman Space Station. Northrop Grumman's design for a modular commercial destination in low Earth orbit is built on decades of experience. The design leverages flight-proven elements such as the Cygnus spacecraft that provides cargo delivery to the International Space Station to provide a base model for extended capability, including science, tourism, industrial experimentation, and the building of infrastructure beyond initial design. This picture shows Northrop Grumman's low Earth orbit commercial free-flying space station. The development of partially reusable rocket launched vehicle designed to go into orbit around Earth to transport people and cargo to and from orbiting spacecraft is making the launch cost to be reduced and enticing many people to travel to space for business and vacationing. In-space manufacturing, also referred to as InOrbit Manufacturing, and involving a comprehensive set of processes aimed at production of manufactured goods in space, is helping to make space profitable and the next step for creating a sustained human presence beyond the Earth. A low Earth depot's primary function will be to provide propellant to a transfer stage headed to the Moon. Several commercial space stations that will provide commercial laboratories, business opportunities, and residential infrastructure in space and home to microgravity experiments are also being proposed. All the in-orbit LEO endeavors will help to increase low Earth orbit economy. You've been watching and listening to InOrbit LEO economic companies. For more information, contact Astronautics for Exploit. Thank you.